We want to turn our attention to production now. So how does a firm know exactly how much quantity of a particular good they're producing to bring out into the marketplace? It does depend on the time. So here we take a look at the short run versus the long run. And if you remember from chapter number 5, where we talked about elasticity, we talked about the time differentiation there, and this is just going to be a little bit of a review from that. Remember, the short run and the long run, there is no specific time period attached with either one of these time periods. It's not 1 year, 5 years, 10 years, 30 years. It has to take a look at exactly what is happening within each of these sort of situations. The short run is a period when at least one factor of production is fixed and cannot be altered. So when we take a look at one of our resources, it is fixed, it is constant, it does not change at all. In these examples, we typically assume that plant capacity is going to be fixed. So our amounts of physical capital do not change at all. It's going to take quite a bit of time for us to build up new plants, etc., etc. So therefore, we consider this one variable to be fixed. And if one of our variables are fixed, we know that we're taking a look at the short run. The long run is a period sufficient for a firm to adjust all factors of production, including plant capacity, meaning that everything is seen as flexible. So plant capacity is flexible, wages are flexible, the amount of workers are flexible, and firms can actually enter or exit the industry in the long run as well. So in the short run, firms cannot enter or exit the industry. They are stuck. In the long run, that is going to be completely opposite. They can actually enter or leave the industry, and this will become a very huge part of the transition from the short run to the long run as we discuss our market structures later on in the next chapters. So keep this in mind. And we want to go ahead and take a look at production in the short run first. So here, when plant capacity is going to be fixed. Remember that production is the process of turning inputs into outputs, and the cost structure does depend on the nature of the production process. So if we're taking a look at the car manufacturing business versus, say, maybe a boat manufacturing business or a house or building making business, the cost is all going to differ and essentially changes a few of the sort of components of our problem. But here we just want to talk about production in general. And there's going to be two terms that we are going to be interested in with production. We take a look at marginal product and average product. So marginal product, like the name implies, we're taking a look at the additional product or the change in product resulting from a 1 unit increase in labor. Average product, on the other hand, is the total output divided by the amount of labor. It just tells us, on average, how much is each worker sort of producing within our firm. Here, marginal product, average product, we're going to hone in on these just a little bit more in this video. So here, take a look at marginal product. Marginal product. So like we said in microeconomics, we hit on the key phrase marginal just a little bit more, and marginal product is going to be the change in total output divided by the change in labor. Change in total output, change in total output divided by the change in labor. Change in labor. And if we wanted to use a shorthand mathematical notation, it'd just be triangle Q divided by triangle L. So change in quantity divided by the change in labor. Essentially, when we increase the amount of workers that we have working for us by 1 unit, what is going to be the change in our output? How much additional output do we get? And in this instance, once again, we hone in on marginal product a little bit more. As we did with marginal utility, the sum of marginal utilities gave us total utility. We can do the same process here. If we take up the sum of marginal product, so sum of marginal product, MP right here, it equals total product or output, so total product. And we use a few interchangeable terms for product. We can also say product means quantity for us. So just here, note that quantity and product are synonymous for us. So if we sum up marginal product for a given amount of quantity, we will know exactly how many goods, what is the total amount of quantity of goods we are producing or giving out into the marketplace. Average product that we have right here, so average product, also ties along the ideas of product in the short run. It's just going to be output divided by labor. So output divided by labor, Q divided by L. Very simple. division problem that we have right there. It tells us just on average how much each worker is able to produce. So we have marginal product, we have average product, we also can get total product by summing up the marginal products, and we're going to be introduced with a very similar table that we did with total utility, marginal utility, and etc., where we take a look at this production data for this particular firm. We have 4 columns. We have column number 1, labor. So exactly how many laborers, how many workers do we have working for us in this windsurfing sale firm? Do we hire 1 worker, 2 workers, 3 workers, 4 workers, all the way down the line? Column number 2 is total product, our Q. So exactly how many windsurfing sales are we able to produce? If we hire 1 worker, we're able to produce 3 of these sales. If we hire 4 workers, we're able to produce 22 of these sales. If we hire 8 workers, we're able to produce 23 of these sales, and then so on down the line. Column number 3 is going to be marginal product. So when we increase labor by a given unit, how much does total quantity or total product change by? Remember, we're taking differences with marginal product. So how exactly do we get this 3 right here? Well, we use our formula, change in total output divided by the change in labor. So here, as we go from 0 units of labor to 1 unit of labor, the change in labor is just going to be 1. So that's going to be our denominator. Our numerator, what is the change in our total product? It goes from 0 to 3, so the difference there is 3. So 3 over 1, that gives us a marginal product of 3. If we hire 1 additional worker, we get 3 additional windsurfing sales. And once again, because we are going by units of 1, you're going to notice that the zigzag pattern emerges just like what it did in the previous chapter with marginal utility and total utility. 0 plus what number will give us 3? There's 3 right there. 3 plus what number will give us 8? It's going to be 5. 8 plus what number will give us 16? It's going to be 8. And like we said before, the sum of marginal products will give us total product. So how do we get this 8 right here? 3 plus 5 will give us 8. So here, the total product for 2 units of labor is 8, and we can just sum up the marginal product for the previous 2 units. So once again, there is going to be a very good relationship that does develop between labor, total product, and marginal product. And you just have to follow along the same sort of methodology, use the equations for every single sort of calculation if you need to, just to stay consistent. So exactly say, how do we get this 4? So here, we go from 22 to 26, so the difference there is 4. The difference here between the labor is 5 minus 4, so 4 over 1 gives us that 4 right there. So same methodology, same equation. Finally, column number 4 is going to be average product. Simplest calculation that we do right here, we just take total product divided by the amount of labor. So how do we get this 3? Q divided by L, 3 divided by 1, we get the 3 right here. How do we get this 4? 8 divided by 2 gives us 4. 5.33, 16 divided by 3 gives us 5.33. It just tells us, remember, on average, how much can each worker produce within our windsurfing firm, windsurfing sale firm. So this 5.5, it just tells us that on average, each of our 4 workers can produce 5.5 windsurfing sales. So as you notice, these columns right here, column 1, 2, 3, 4, detail exactly production in the short run. And there's going to be a very good relationship that does develop between every single one of these variables right here. So as we increase labor, what happens to our total product? What happens to our marginal product? What happens to our average product? What happens with the relationship between marginal product and average product as labor increases? So go ahead and take a closer look at this table into detail and see if you can see some of the relationships developing as we increase our labor. So what happens to Q, MP, and AP, and the types of relationships that do develop between each of these variables as well. Take a closer look at the data. Also see if you can graph all these sort of things out. So what do you think the MP curve is going to look like? It's going to have a rising, decreasing, or sort of neutral slope or 0 slope. Same thing with average product as well. We want to go ahead and see what these look like graphically on the Cartesian plane as well.